Hello, everybody. Almost done with Unit 8. We got 2 more to go. Lesson 6 is one that a lot of people actually do enjoy. I think it makes a little more sense than some of the other stuff we've done. So today we're going to hopefully be able to solve radical equations and determine when a radical equation has no solutions. So what is a radical equation? A radical equation is an equation that has a variable inside the radical. So real quick, I want you to take a look at this first example. Which of the following is not a radical equation? Okay, A, B, C, or D. The reason that choice B is not a radical equation is because the variable is not under the radical. Square root of 4 is just 2. You can just get x equals 7. You don't need radicals to do this one. All the other ones are radical equations. Okay, to solve a radical equation, you must first get the radical expression by itself on one side of the equal sign. Okay, so I'm going to talk about that several times, not only in these notes, but in class. What is the radical expression in part A? Well, the radical expression is radical x. In part B, the radical expression is the radical 3x minus 5. So to get these by themselves, we need to move the numbers on the outside of the radical to the other side of the equal sign, just like we do when solving an equation. So I need to move the 3 and the 8 in a specific order. And on B, I need to move the 2 and the 1. Okay, so we're going to do that. So I'm going to subtract 8 first, just like I would with a normal equation. So I have 3 radical x equals 12, and then I got to divide by 3. So I get square root of x by itself, that's what I wanted, equals 4. On part B, I'm going to subtract 1. I'm going to have 2 radical 3x minus 5. One of the common issues I see is people try to distribute the 2 into 3x minus 5. Don't do that. That doesn't make any sense, actually. You can't. 15 minus 1 is 14. I'm going to divide everything by 2. And I get the square root of 3x minus 5 by itself equal to 7. Once you do this, you are still not done with the problem because we don't have the variable by itself yet. We have to get rid of the radical. How do we do that? Remember from lesson 1, the operation that undoes a square is a square root. Well, the opposite's also true. What operation undoes a square root is a squared term. It's to square both sides of the equation. So what we're going to do is we're going to square both sides of these equations. So I'm going to square this and square this. What that's going to do is it's going to cancel the radical, and I'm going to get x equals 4 squared is 16. Same thing over here. I'm going to square both sides. Now watch what happens on B. It's a little bit trickier on B because squaring it cancels the radical, and I'm left with 3x minus 5 equals 49. Okay. I still got a little work to do. I don't have x by itself yet. I just couldn't move the 3 and the 5 yet until I got rid of the radical. I got to get rid of the radical before I can move the 3 and the 5. So I get 3x. This is now literally back to the beginning of the school year. Divide by 3, I get x equals 18. Okay. So I got 6 here to try. Get the radical expression by itself. The radical expression is radical x. I need to move the 7. So the square root of x equals 5. I am not done. I got to get rid of the radical now. Square both sides. I get just x equals 25. A good thing to do is to mentally check it. Take 25 and put it back in for x. Square root of 25 is 5. 5 plus 7 is 12. It worked. All right, number 2. The radical expression is radical 2x. I need to move the 3. Divide by 3. I get the square root of 2x equals 4. Don't divide by 2 yet. I need to get rid of the radical. Just getting rid of the radical. All I have is 2x now equals 16. Now divide by 2 and you get x equals 8. Again, check it. Put 8 back in. That's 2 and 8 underneath the radical. 2 times 8 is 16. The square root of 16 is 4. 3 times 4 is 12. Next one, the radical expression is actually already by itself here. Don't have to move anything. I'm going to square both sides, and I'm going to get 2x minus 3 equals 49. Now I just got to get x by itself, add 3. 52 divided by 2, x equals 26. Plug it back in. 2 times 26 is 52. 52 minus 3 is 49. Now I take the square root. Square root of 49 is 7. Number 4. Radical expression is x plus 4. I want to move the 3 and the 5. I have to move the 5 first. So I have 3 radical x plus 4 equals 12. Divide by 3. I have the radical x plus 4 is equal to 4. Now I get rid of the radical by squaring both sides. I get x plus 4 equals 16. Subtract 4, I get x equals 12. 12 plus 4. Notice I'm verbally checking it right now. You should be mentally checking it. 12 plus 4 is 16. 16 square root is 4. 3 times 4 is 12. 12 plus 5 is 17. Okay. I'm going to make a mistake on number 5. Okay. I'm not really sure where I want to make my mistake yet, but I'm going to tell you that I'm going to make a mistake so that I can see where checking can be helpful. So add 7. All right. And I'll get square root of 5x plus 3 equals 3. Now I'm going to square both. Okay, so 5x plus 3 equals 9. Okay, I'm going to add 3 and say 12. Divide by 5, I get x equals 12 over 5. Okay, now I'm going to plug that back in. 5 times 12 over 5, you might be like, I can't do that in my head. You actually can. 5 times 12 is 60. 60 divided by 5 is right back to 12. Okay, 12 plus 3 is 15. The square root of 15, is not a good number. I did something wrong. You probably noticed it pretty quickly. I should not have added 3. I should subtract 3. That's going to give me 6. 6 divided by 5 is actually just leave it as a fraction. 6 divided by 5. Okay, take that and plug it in. 5 times 6 over 5 is 30 divided by 5. So 6. 6 plus 3 is 9. Square root of 9 is 3. 3 minus 7 is negative 4. And it works. Last one. My radical expression is a fraction here. Don't freak out about that. Just do the same thing. I'm going to get rid of the 1. Plus 1 is 15, and then divide by 5. So I get square root of 3x over 4. Hold on, I'm not going to write it like that. That's confusing. Make it bigger. 3x over 4 is equal to 3. Now I'm going to square both, and I get 3x over 4 equals 9. I'm going to multiply by 4. You know how to do this, right? You should. 3x equals 36, and divide by 3, x equals 12. Take that, plug it in. 3 times 12 is 36. 36 divided by 4 is 9. The square root of 9 is 3. 5 times 3 is 15. 15 minus 1 is 14. All right, so that's radical equations. There's one more that I want you to do. I got several more that I want you to do, but there's one here that's tricky, and I want you to do this one first before we do the last 6. When you get the radical expression by itself, what does it equal? So I'm going to subtract 8. I get the square root of x equals negative 3. Can you take the square root of a number, any number, and get negative 3? Hopefully you're catching on that. No, you can't. The square root of a number cannot be negative. It doesn't make any sense. Okay? Therefore, this problem has no solutions. This is something you want to check for once you get the radical expression by itself. don't fall for the trick on number one. I tried to do it right away. The trick on number one is, oh, look, it's equal to a negative, no solutions. Not true. You have to have the radical expression by itself before you can say that. So I need to add 7 first before I can say anything. So I get the square root of 4x equals negative 5 plus 7 is 2. And that's positive. So now I can actually square both sides. I get 4x equals 4 and x equals 1. All right. Again, number 2, I tried to trick you again. It's equal to a negative, but I need to get rid of that negative 3 first. Divide by negative 3, I get the square root of x plus 1, and a negative divided by negative is positive 7. I can still square this. So x plus 1 equals 49. Subtract 1, I get x equals 48. Next one. I am going to first subtract 6. I get negative 2 radical 2x minus 5 equals 10. Divide by negative 2. I get the square root of 2x minus 5 equals negative 5. That's impossible to happen. You get no solutions. Now, if you're not watching for that, it's very easy to continue and get the wrong answer. Okay, and I'm going to do that again in one of the remaining 3 problems. I'm going to show you what happens if you do continue on. Okay, number 4, you haven't seen anything like this, but it's actually very easy. I have 2 radical expressions. If I just square both of them, I get an equation like we had back in August. I'm just now going to get x by itself. Subtract 3x. I get 4 equals 2x minus 6. Add 6, I get 10 equals 2x, and x equals 5. Pretty easy. Plug that back in. 3 times 5 is 15. 15 plus 4 is 19. The square root of 19 is not a good number. But let's look at the other side. 5 times 5 is 25. 25 minus 6 is 19. The square root of 19, although it's not a good number, is equal to the square root of 19. So we're good. Number 5. Subtract 8. I get negative radical 2n equals 12. Divide by negative 1. I get radical 2n equals negative 12. Okay. Radical expression by itself, I'm going to square it. I get 2n equals 144. N equals 72. Now, if I check this, 2 times 72 is 144. The square root of 144 is 12. 8 minus 12 is not 20. What happened? A lot of you probably noticed it. I got the radical by itself, and it was equal to what? It was equal to negative 12. That's why it's important to watch for that. This one has no solutions. You're going to keep going, and you're going to get a good number a lot of times. You will get a good number a lot of times. And you're going to think you're good. 72 seems like a reasonable answer. However, if you plug it back in, you find that it's not a reasonable answer. And then that takes you back, and you look at your work and you realize, oh, wait, this has no solutions. Okay, last one. Like number 4, I have to do is square both sides. So I'm just going to set both inside and outside equal to each other. I'm going to add x to both sides. I get 2x plus 10 equals 6. I'm going to subtract 10. I get 2x equals negative 4. I get x equals negative 2. Is it okay to have a negative x value? Yes. Take that negative and plug it back in for x. Negative 2 plus 10 is 8. The number under the radical is still positive. That's good. That's what we want. Square root of 8. Look at the other side. 6 minus negative 2. Minus a negative is plus. So 6 plus 2, 8. Square root of 8 equals the square root of 8. We're good. Okay. The only thing you can't have is the radical is equal to a negative number. X can be an equal number, a negative number, but the radical cannot equal a negative number. Okay. That's about the only tricky thing in this lesson, I think. That's it. one more lesson to go in Unit 8.